This is geometry, practice test 10. In number 1, we're asked to identify the major arc. This word major means I'm going to be having 3 letters for U, Q, V. So for U, Q, V, it's really not talking, this is the minor arc, right? It's really asking about this major arc right here. So to name that arc, I can say U, and then it's going to end with V, and it's going to have an arc. It has to have 3 letters, which means I need a letter in between, and I can choose any letter in between U and V. I can choose either T or S, it doesn't matter. I'm just going to randomly say T. In number 2, I'm asked to identify angle 5 as an arc, right? So angle 5 is right here, therefore the arc it's talking about is right here. So I understand that this is a minor arc, therefore I only need the 2 letters B and F. It doesn't matter which order I give them in, B and F with the arc. In number 3, we're just doing the central angle. We're going backwards in this case. Notice I have 3 letters here, meaning it's probably a major arc. F, H, G. So F to H to G means I'm going F to H to G. So the arc that it's talking about is right here, and that angle is 1 plus 4 plus 3 for the major arc, but we can't name 3 angles, so it must be talking about angle, the backside of angle 2. So F, H, G, while it's talking about that arc, the only angle that we can talk about is the outside of 2. What's interesting here, this is going to be angle 2. What's interesting here is this feels backwards, right? Because angle 2 is clearly talking about that arc right here. That's the corresponding to angle 2. That's the thing with angles. Like if I were to draw an angle, what am I talking, like all you have is this information. I didn't say it's the inside. I didn't say it's the outside. Angles have an inside and it can be an outside. It can be either or. So angle 2, I'm not talking about the inside of angle 2. I'm talking about the outside of angle 2. I was talking about that outside. So a bit confusing, but hopefully we're okay. In number 4, we're talking about EIH. So again, if I'm looking E to I to H, which looks like we're talking about this right here, we need to be talking about, well, I need to talk about, you can see E to I to H was really this angle right here. So all I have to do is identify that angle, and I can go E to Q to H, or I can go H to Q to E. It doesn't really matter. I'm going to go E, I want to do it red though. Oops. I'm going to go E to Q and then to H for my angle. And I could have done HQE, it doesn't really matter. All right, number 5. We just need to find the measure of the arc. All right, so, or the angle in this case. So I have a central angle because it says angle here. So GKJ. So GKJ. So I'm talking about this angle right here, and I'm trying to find the measure of that angle. So I can be talking about that interior angle. Typically, it's the interior angle. It doesn't always have to be. It can be that outside angle as well. We're going to assume the interior angle unless it tells us otherwise. So GKJ, I'm going to say is this angle right there. So I need 48 plus this angle that I don't know. So is there a way to figure out that unknown angle? Well, yes, because this interior angle of 65 is really the arc measure out here. So this is 65 degrees for the arc measure. And all of these arc measures, including the one that we don't know, add up to 360. So I can say 48, and I can just do a long list of these. 48 plus 87 plus 65 plus 60. Let's add that up and figure out what's going to go on. Because really what I'm doing is I'm trying to add x to this, and that adds up to 360. So what I'm going to do is I'm going to exclude that and figure out how much to subtract from 360. So let's add these up. So we have 8 and 7 is 15, plus another 5 is 20. So there's the 0 and the 2. And 2 and 4 is 6. 6 plus 8 is 14. 14 plus 6 is 20. 20 plus 6 is 26. So I get 260 here. And that means that the remaining angle, this x, has to add up to 260 to get 360. So x plus 260 adds up to 360. If I subtract 260 on both sides, minus 260, minus 260, we see that x is going to be 100. So we know that this angle right here is 100 for that arc measure, which is the same thing as the central angle. That's also 100. So what I'm really talking about for GKJ is these two angles, 48 plus 100 added together, and that's 148 for number 5. So I'm going to come down here and say 148 degrees. Number 6 is on the next page. All right, number 6. solve for x and assume that you see any lines that appear to be diameters or actual diameters. None of those lines appear to be diameters. They would have to go straight through. They would have to go straight through, straight through. None of these go straight through, so there's no diameters in this case. We just need to solve for x. So x is part of this 8x minus 4, which is this central angle. So we probably need to add up all of these angles here. We have 47 is that central angle, 70 is that central angle, 69 is that central angle, 90 is that central angle, and this unknown one, which we don't have. So let's go ahead and add these things up. And I'm going to make an equation right off the bat. I need 8x minus 4, that's one angle, plus 47, plus 70, plus 90, plus 69. All of those should add up to a full circle, which is 360 degrees. I'm leaving out the degrees to make this go faster. All right, so what do we have here? These two add up really nicely, so let's go ahead and say that those two change into 160. We'll do arrows so I can remember what happened here. And then I have these three terms. I'm thinking that this one and this one go together nicely, so it's going to be 43, and 43 plus 69, well, 4 and 6 make the 100, and then the 3 and 9 make it 12, so it's going to be 112. So plus another 112, and that came from U, and an arrow over here, U. So I can keep track of my work. And then this, if I add those two together, 112 plus 160, that adds up to 272. So I have 8x plus that 272 is equal to 360. Let's subtract the 272, so 2 minus 272. That means we have 8x is equal to, what do we have here? I need to borrow, so you're going to turn it into a 2, you're going to turn it into a 16, but I need to borrow from here again, so let's turn it into 15 and 10. So I do 10 minus 2 to get 8. I do 15 minus 7 to get 8. So it's just 88. All right. And then from here, I divide both sides by 8. So we're going to say divide by 8, and x here is equal to 11. Just be careful. There was a question asking for an angle or x. It was actually asking for x, so, and I got x is equal to 11. So let's just box that. X is equal to 11, box, and done. Not the best box, but we're going to call it good. Number 7. Find the measure of the arc or central angle. So we're looking for central angle, because it says angle here, not an arc above this, can't speak. TVS, so TVS, so it's talking about this angle right here, which is the same as the arc measure, x plus 76. So what we're really trying to find is x plus 76. Don't just solve for x, we'll find x and then we'll plug it into here. So what do I notice about this thing? I notice that this entire side is on the diameter. Diameter is 180 degrees, so this side is also 180 degrees. Does that help me though? Because it looks, oh, this is a diameter and this is a diameter, therefore these two angles are the same. I wonder if that's going to help me. If those angles are the same, we don't know any information about this one or this one. Oh, but check this one out. By the inverse of that, the squiggly line, this squiggly line, and this squiggly line, therefore, are also the same. So to see that, temporarily, ignore this line. Can you see that these diameters mean that this length that or this area shaded in here is this area shaded in here? They are the same areas. Therefore, this length and this length, or I guess these are angles. These angles add up to that angle, just because those are both diameters. So you can say that x plus 76, that's one angle, plus x plus 53. Those two angles are the same thing. If I add these two, that's the same thing as this one, which is 105. All right, we've built our equation, which I think was the hardest part of the problem, and then we just used simple algebra to solve. What do we got? 76 and 53, they both end in 6 and 3, which is 9. 5 and 7 is 12. And I have two of those x's, and that's going to be equal to 105. Subtracting 129, ooh, that's going to be a negative 129 minus 129. It's okay to have negative values. You can't have negative angles, though. So I have 2x here is going to be equal to negative 24, and then dividing by 2, x is going to be equal to a negative 12. Okay, that's not what the question was asking for. It didn't say what's x. It's asking for the measure of angle TVS. So I'm going to plug this 12 into this x, and we're going to say, We're going to say we originally had x plus 76, but we know that this negative 12 is being plugged in for this x, so I really have negative 12 plus 76. And 76 minus 12 is 64. I'm going to say 64 degrees is what we're looking for. All right, and that completes number 7. Moving on to number 8. Ooh, we're going to need a calculator for this one. Maybe. All right, so we're just solving for x. Find the length of the segment indicated. So we're just finding x and just reading the instructions. Round our answer to the nearest tenth if necessary, so 1 decimal place of accuracy, and a calculator is required. We'll see about that. So for this one, it's saying, hey, the radius here is 12. It's saying that that piece right here is 5.3. We'll define x. If this radius is also 12, then this 5.3 and x have to add up to that full length of 12. I can say that with a formula to make it formal, but it's really, I just do 12 minus 5.3 and I call it a day, because 12 is the radius, and that was a terrible 5, and 5, come on, Mr. Snow, 5.3 plus x, that also adds up, whoa, I'm just really out of shape with my curly brace, is also the radius. So the radius is set equal to the radius, and you just subtract 5.3 minus 5.3 minus 5.3, and therefore x is equal to, well, 12 minus 5 is 7. I have to go a little bit lower than that, 6 to borrow, and 10 minus 3 is 7, so 6.7. I get my final answer. All right, let's try another one. Number 9. Hopefully this one's going to be a little bit harder. Indeed, it is a little bit harder. I'm just trying to find this length of x, and I have the radius, which happens to be the hypotenuse of this right triangle, and I also have this lower piece. Really, if you can ignore the circle, really, I'm just talking about the triangle. All I needed to see was this problem right here, right? This problem is saying, hey, x is right there, 90-degree angle there, this length is 4.7, and this length is 11.5. This is simple Pythagorean theorem, and that's saying that the leg squared and the other leg squared add up to make the hypotenuse squared. So I can say the original formula is a squared plus b squared is equal to c squared, where I can say that that's a, that's b, and that's c. Again, c has to be the one across from the 90-degree angle. These two are interchangeable. You can swap them. It doesn't really matter. So let's fill in our formula. We say that x squared plus b, which is this 4.7, is going to be squared, and that's going to be equal to our c, which is 11.5, which will also be squared. All right, so doing that, simplifying x squared is still x squared. 4.7 squared, okay, fine, they were right. A calculator would be nice for that one. So let me go ahead and break out my scientific calculator. All right, so what do we have here? 4.7 squared, what are you? You are 22.09, so I'm going to say plus 22.09 is going to be equal to 11.5 squared, which is 132.25. And then from here, we just need to move 22.09 to the right side by subtracting 22.09 on both sides. So I can say I can do answer, subtract 22.09. And we can say that now that will make it so that x squared, because these two cancel, right? X squared is now equal to 110.16. And then from here, I need to get rid of this pesky power of 2. The way we undo powers of 2 is we take the square root. Square root of the left, square root of the right. Normally, you have to do a plus or minus whenever you do a square root, but in geometry, you can't have a negative length, so we're going to ignore the negative. We know it's going to be a positive. I'm going to say it's a positive, whatever that is. I'm just going to say a square root of the answer. And that's going to be about, okay, so it's an approximation. So let me get rid of the equal to sign. It's about, so it's approximately equal to 10 point, okay, now I'm going to round to, did it say 1 decimal place? To nearest 10th, so 1 decimal place. So 10 point, it's going to round up to 5. 10.5 is what x is approximately equal to. I'm going to box that. It's approximately 10.5. No units here, no inches or centimeters or whatever. What about number 10? I'm guessing that's going to be the hardest out of all 3. That's usually how Mr. Sandell makes his tests. Yes, this is a bit harder. Okay, so what is 24? 24 is this entire length of the diameter. X is this piece right here, and 10.6 is this piece right here. We're missing a lot of information. So what is useful to know is pieces of that triangle. I think that's the key to unlocking this problem. Usually that's the key for these types of problems. Let me go ahead and redraw that triangle out here to the right. I'm going to go ahead and say, there's my flat line, and make that a right triangle, please. It tried. Okay, so there's my right triangle. I know that this length right here is the radius, which is half of 24. Therefore, that length is 12. I also happen to know that whenever I have a right angle right here, that this length here and this length here are the same length. Therefore, 10.6 is that length up here. I can say 10.6 goes here. And I don't know what you are. Let me call you y. I want to call you x, but x is already taken. So I'll call you y. If I can figure out y, then I'll have that length. And I can just do the radius, this entire length is 12, minus this number to get x. So let's find y first. So again, this is just Pythagorean theorem. This is a squared plus b squared is equal to c squared. You'll see that a lot throughout all of mathematics. Even in calculus, you use a squared plus b squared equals c squared. Let's go ahead and say you're a, you're b, and you are c. So it's going to be y squared plus b, which is 10.6. 10.6 squared is equal to c, which is 12 squared. And we have a calculator, so I can do this a little bit faster, but I know y squared is still y squared, nice and easy, plus 10.6 squared. Don't know what that is off the top of my head. 10.6 squared is 112.36. It's going to be equal to 12 squared, which I do know off the top of my head, which is 144. And then I have to simply do 144 minus that previous answer. So I say, what I really did here was I subtracted 112.36 on both sides, minus 112.36 on both sides, meaning that you are gone, leaving the y squared, which is equal to this 31.64. And then finally, to get rid of this pesky power of 2, you square root it. So if I square root both sides, square root both sides, and again, I always give this warning, you should be doing plus or minus every single time you do this. In Algebra 2, that'll come back to bite us. But for now, I know that this answer has to be positive, so I ignore the negative, and I just say, okay, the answer is positive, and it's going to be positive, whatever the square root over here is. It's going to be the square root of that answer, which is about, again, it's about, so I should get rid of the equal to sign, make this a wavy equal to sign, meaning it's approximately 5 point, and then 1 decimal place, so that 6 stays a 6 because it's followed by a 2. So about 5.6. This is not the answer. This is this length right here. We have found that that length is about 5.6. 5.6, which means this entire length is half of 24. This entire length is 12. We're going to do 12 minus 5.6 to find x. So if you don't know how to do that, you can use a calculator. 12 minus 5.6 is 6.4. You can say that to show your work, so Mr. Sandel can follow what you did, you can say, hey, I know that 12 is the same length as that length of, you can say, if you want to be really cool, you can say x plus y. And we just found y, so 12 is equal to x plus that length of 5.6. And if I subtract 5.6 on both sides, subtract 5.6, x therefore is equal to 6.4, which is the thing we were looking for. Again, it feels a little bit weird to write an equal to sign since we already did an approximately equal to sign, but it is good enough. So 6.4 for number 10. All right, number 11. Find the area of each. Use your calculators. So I have a calculator over to the left. Value of pi. Round your answer to the nearest tenth. Just remind myself I do have pi as one of my buttons. All right. So I'm finding the area. Area. If you do have to have this memorized. It's going to be area is equal to pi r squared. And hey, we have a radius right here, so you just plug this in. This is going to be equal to pi times 9 squared, which is 81 pi. I mean, normally that would be a nice answer, but we want to practice using pi and rounding it to the nearest tenth. So I just need to type in 81 pi, and it says, hey, that is approximately 254 point, okay, what are we rounding to? It says round your answer to the nearest tenth. Tenth means 1 decimal place. So it is 4, 6. That 4 is going to go up to a 5 because it's followed by a 5 or greater. So 254.5. And then we do have units here. So be careful. We have centimeters, which is a unit of length, or a unit of length for like circumference. Whenever I talk about area, it's power of 2. Whenever I talk about volume, it's power of 3. It's the dimension in which you're talking about. Area is the second dimension, so this is going to be centimeters squared. All right, in number 12, we have circumference. Okay, so let me draw a picture of what's happening here. I have some circle. It's going to think I'm doing an oval because I'm really bad at math or drawing. There, okay, I have a circle, and I know that this distance from here all the way around, that was maybe not my best picture, but is 50.9. So what I'm essentially using is a formula to find radius. What I need to find is radius. And then once I have radius, then I can plug it into this formula right here. So what do you know about circumference? I know circumference is equal to 2 times pi times the radius. How do I know that? It's because the definition of pi. If you don't know this, I'm maybe failed as a teacher, but pi, by definition, is the circumference divided by the diameter, which means if I am trying to get c by itself, I undo divide by d, and I multiply both sides by d, multiply both sides by d, which means those are gone. And hey, circumference, by definition, is pi times diameter, and diameter is twice the radius. So that's the old-fashioned definition. This is the one that you'll be memorizing over and over on the test, and we just need to plug things in. So I know that the circumference is 50.9, so that gets plugged in, and that's equal to 2 pi radius. The thing I need to solve for is a radius, which means I need to get rid of multiply by 2, get rid of multiply by pi. I'm going to divide everything by 2 pi. Divide by 2 pi, and our 2 pi's are gone, leaving behind our radius, which is now going to be approximated with the calculator as 50.9 divided by 2 pi, which is, oh my God, almost on the dot, 8.1. So if the radius is about 8.1, then I can come back to our other formula for area. The area of a circle is pi r squared, and I can come back here and say that's pi times our new radius, which is 8.1. We just found that, and that's going to be squared. So I can come down here and say, what is pi times 8.1 squared? And you get about, because we're approximating here, 206.1, just rounding to one decimal place. So, and I'm realizing that the answer key is 206.2. So maybe a more precise way of doing this is answer squared. There we go. So I didn't round at all here. So I rounded here, but then on my calculator, I ended up just using the previous answer. And you can see without any rounding, except for the very, very end, this is 206.17. And because this is followed by 7, this 1 changes into a 2. And we can say 206.2. Only rounding at the very end, which is what all good math students and physics students and any sort of mathy-ish discipline students should do. Only rounding at the end. Oh, whoa, 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 whoa. Units. Our units here are always going to be that quantity squared, right? So let me change this to, we were talking about miles, so let's talk about miles to the second dimension. Miles squared. Now I feel good about that. All right. Moving on to number 13. Find the circumference of each circle. Okay, well, I'm going to use that very, very ancient definition of pi is equal to circumference times diameter. Maybe you don't like that. Maybe you're more of the, I prefer, I'm a classic pi is equal to 2 pi r type of person. Either way is going to work. Why'd I say, both of those are wrong. My brain just like glitched there. I am so sorry. No. Let me rewrite these. Circumference is equal to pi times diameter. That is a correct formula that I wanted to use, but I think I'm going to go for the circumference is equal to 2 pi r here. Weird brain glitch. I am super duper sorry about that. So embarrassing. So how do we do this? Well, I know that the diameter is 8. So I can just come over here and say circumference is equal to pi times 8, which, do we need to round? Yep, we need to round to the nearest tenth. So I just type in 8 pi and I'm done. This is about, wavy equal to sign, this is about 25.1-ish. If you did over here, you'd have to divide the 8 into 2 pieces. So this is 4, and you'd say this is equal to 2 times pi times 4 for the radius, which is equal to 8 pi, which again is equal to 25.1. Don't forget our units here. Circumference is a unit of length. How far have you walked? I've walked 25.1 meters around the outside of the circle. So we're going to put in an M here for meters, 25.1 meters. All right. Number 14. Length of each arc, and we're still using a calculator. So I can clearly see that the bold length is talking about this length right here. How far did I walk? Whenever I talk about arc length, the general or partial area or sector area, whatever we call those things, it's always going to be a very simple formula of percent times the thing that I want, percent times my circumference. And that's a very simple formula. A slightly more useful formula would be the partial amount divided by the total amount times the circumference. So a percent is the partial divided by the total, and then circumference, I just wrote out circumference a little bit more to make it look cooler. So I need to figure out 210 is a part of the circle. The entire area, or the entire angle of the circle is 360. So 210 comes up here. We're going to say our formula gets filled in with 210 divided by the total, which is 360, and then we just multiply that by the circumference, which I happen to know the formula for. It's 2 times pi times the radius. So this is all set up, except for the fact that radius, we know. The radius, it told us, is 12 inches. So when we come back over here and erase the r and say, this is really 12. And that's the answer. So I just need to type this all into the calculator. I'm allowed to use a calculator because it wants me to round my answer to the nearest tenth. So let's just type all this stuff in. 210 divided by 360. So I'm talking about 58% of the circle. And I'm going to multiply that times 2 times pi and times 12. And we get our answer. This is equal to, again, I'm approximating here, so this is roughly equal to 43.98, which means this is really 44.0 if I'm rounding it. And what are our units here? We're talking about the length here. Length is in the first dimension, so just inches to the power of 1 or just inches, so 44 inches. All right, what do we have down here, number 15? Okay, so sector area. So sector is the same thing. It's the percent of, not the circumference now, it's the percent of the area. So my very basic formula is it's the percent of the area. So percent times the area. And percent, more specifically, is the partial divided by the total times the area, which is pi r squared, when I'm talking about a circle. So my partial in this case is 120 degrees. So I have 120 degrees. The total degrees of a circle is 360 degrees times pi times radius, and that radius is going to be squared. Our radius in this case, it's clearly saying the radius is 19 meters. So I plug in a 19, and I just have to type this into my calculator, and I'm done. I just say, okay, 120 divided by 360 times pi times 19, and 19 is going to be squared, is equal to, and then again I'm approximating here, this is roughly equal to 378.0, because it's followed by a 3, so you don't round up. 378.0, and then what are our units here? We're talking about meters, so we're in the second dimension because we're talking about areas, so it's meters to the power of 2, meters in the second dimension, meters squared. Excellent. Moving on to number 16. Find the measure. Okay, I don't think we need a calculator anymore, so let's hide the calculator. Find the measure of the arc or angle indicated. Okay, it's clearly indicating this angle right here. Ooh, this one is like tricky. All right, let's see what I got. I know that this is called an inscribed angle because the angle's on the edge of the circle. What do I know about inscribed angles? Inscribed angles, if I double this angle on the other side, this piece right here is always double that. So I know that this length, I'll do it like in blue, this length right here is equal to 102 degrees. Don't know if that helps me, but I also know this, that this entire line is a diameter. Diameters have 180 degrees, which means this entire thing should be 180 degrees. I mean, it's cutting the circle in half, right? I have 180 there, another 180 there. Kind of looks like Saturn. This has to be 180, which means I can figure out, I'm going to go ahead and call this length right here. That length right here is x. I know that 102 degrees plus x has to add up to 180 degrees because it cut the circle in half with that diameter. So why is that going to help me? Because this angle right here is kind of referring to this piece. So it's really helpful to know that piece. That's my logic. So from here, we just subtract 102 minus 102. That degree symbol is kind of messing with me, so I'm going to get rid of it. It's going to be equal to 78 for x. So we can come back over here and say that's really 78. Sure, we'll put degrees right there. That's supposed to be a degree symbol. And so if I have an angle, or sorry, an arc measure over here, and I'm trying to get to an inscribed angle, I have to divide it by 2. So 78 divided by 2 is really, I don't actually know it, but I know that 80 divided by 2 is really easy. 80 is close to 78. And that's equal to 40, so it's probably a little bit less than 40. It's probably 39. So I'm going to say our question mark is equal to 39. So the question mark here is equal to 39 degrees. Nice. Let's move on to number 17. Solve for x. Okay, so it's another inscribed angle problem. On this inscribed angle problem, I have the only place where I have an x is right here. So I have to somehow figure out this angle, which is an inscribed angle because the point here is on the edge of the circle. So this inscribed angle is really talking about this entire length up here. So if I can find this arc measure up here, I'm kind of done. And hey, I can find that arc measure because this entire arc measure right here, I can just do 360, the entire circle, minus this piece to find that whole piece. So let me say that as an equation. I'm going to say, hey, I can get 360 degrees if I add together all of the pieces. I'm going to go ahead and I need to make this a variable name. So I'm going to call this thing right here, let's call that y. If I don't like the degrees in my equation. So if I do y plus 64 plus 92, all of those three pieces should add up to 360. Let's simplify 64 and 92. So that's going to be a 6 there, 6 and 9 makes a 15. So 15 with a 6 is 156. And we're going to subtract the 356 to both sides. So minus 156, minus 156. That was 156. It's really close to subtracting 150, which would be doing two there and a 1 there. It's a little bit more than that, so it's going to be 204. I'm thinking 204 here is equal to y. And so if that is 204, then I was going to say unfortunately, but that's not the final answer because I have to do an inscribed angle. I always have to do this length and then half of it to get to the inscribed angle. So half of 204 is going to give me 19x plus 7 is really equal to half of 204. So I'm just going to say 102 right here, 102. All right, so I did a bunch of work, and now I have a simple algebra equation. I just say, okay, let's subtract a 7, subtract a 7. We'll get then 19x is equal to 95. Are those things divisible by one another? I'm thinking 95 divided by 19. Oh, wait, that's 5. Okay, hold on. I can just say divide by 19 divided by 19. X here is equal to 5. What were we trying to solve for? It said to solve for x. I got x. X is 5. So box that. X is equal to 5. All right. Number 18. Okay, yeah, it's these are chords, intersecting chords. So the way that I've always remembered intersecting chords is these two angles are the average of this angle and this angle. I don't know if that's what you guys would like to remember, but that's how I remember it. So I'm going to say that 74, which is this, I don't want degrees though. 74, which is this angle, which is also the same as this angle. They're vertical angles, so they're the same angle. This is the answer to the average of these two. The way that you do average is, I'm going to go ahead and call this thing x. The way that I do average is I add that thing and I add that thing and divide by 2. 74 is equal to x plus 60 divided by 2. And I just solve. So I'm going to multiply both sides by 2, so those are gone, and I have 148 on that side, and I have x plus 60 on that side, and subtract 60, and x here is going to be equal to, 14 minus 6 is going to be 8, so it's going to be 88. X is equal to 88 for number 18. There is also another way to do this problem. I don't know if anyone is interested. But here's the way that I first tried to do this problem to get 88. The way that you do averages, if this is the middle number, how much do you have to move from 60 to 74? And that same jump here is going to be the same jump to get from here to here. So for example, to get from 60 to 74, I add 14. 1 to 6, 4 to 0 gives you 74. If I add 14 again, it also works. 74 plus 14, you guessed it, is 88. That's another way to memorize it, although sometimes the addition here can be a little bit tricky. What about number 19? Oh, the ice cream cone theorem. So I think the ice cream cone theorem states big minus small is equal to twice of that thing. That's, I think, the way that you do this. So let's go ahead and say, oh, the problem is we have the small. We need to figure out the big. So to figure out the big, I know that this one and this one add up to the entire circle. So I can say that as an equation to show my work, I can say 125 plus, I'm going to go ahead and call this length over here, let's call it y. Let's call this thing x. If I do 125 plus y, that should add up to 360 degrees. Therefore, if I subtract 125, subtract 125, y here is equal to 235. And then, so I have big now. I can say you are equal to 235. So my general equation that I have memorized is big arc minus small arc is equal to 2 times the angle. So my big arc in this case is 235 minus my small arc, which is 125. Come on, brain is not brainy, is equal to 2 times my angle, which I don't know, so we're going to call that x. All right, so that's a pretty simple subtraction problem. 25 from 35 is 10. 200 minus 100 is 100, so 110. 110 is equal to 2x. Divide both sides by 2, and x is, I should show my work. Divide by 2, divide by 2. X here is equal to 55. Do I need a degree symbol? Yeah, I probably should. 55 degrees. There we go. All right, number 19, 55 degrees. Moving on to number 20. Kind of the same idea. You're doing the same equation where you do the big arc minus the small arc, and that's going to be equal to 2 times the angle. The big arc here is I'm going to call that the x. So we're going to say that is equal to an x. So what I have is an equation. I have x minus the small, which is 64, and that's going to be equal to 2 times the angle, which is 43. Just need to solve for x here. 2 times 43 on the right here becomes 86. So x minus 64 is equal to 86. If I simply just add 64 and add 64, x here becomes 6 and 4 make a 0, carry the 1, 8 and 6 is 14, plus 1 is 15. So 150 degrees. X is the thing that I assigned, so I'm only boxing the 150 degrees for number 20. I guess I really should have only boxed the 55 degrees over here since I invented the X on my own. 55 degrees. Box in a different color, but we'll take it. All right, number 21. Okay, so we're dealing with lengths. So whenever you have chords that intersect, like we do here, we're just going to say u times u is equal to u times u. Set up your equation. You're going to say what I just said. You said 9 times x plus 2. You multiply those two lengths, and that's equal to multiplying the other two lengths. 15 times x minus 2. Multiply both, then you get the right answer. All right, what do we get here? I'm going to distribute each of these. We get 9x plus 18. Distribute. This is going to be 15x minus 30. And let's go ahead and move the x to the left side. Minus 9x. Minus 9x. So those are gone. And let's also move the 30 to the other side. Plus 30, plus 30. So that means that's gone. And we're left with 30 plus 18 is 48. 15 minus 9x is 6x. And then finally, divide by 6, divide by 6. X here is 8. Do we need a degree symbol? I don't think so. This is talking about a length, right? So I think it's just 8 units or whatever. X is assigned by the problem, not by us, so I can box the X as well in this case. Number 22. These ones, again, you just you have to be careful though, because I remember this one is like big times small is equal to big times small is how I remember this. And big, unfortunately, means you have to add these two together. So this entire length here, let's be careful. This entire length right here is 9 plus x. And this entire length right here is 8 plus 19, which is equal to 27. And the small is just the 9 and 8. These are not considered the small. The small is like, you have to be part of the angle. So the angle starts down here. It has to be at least have some part of that. That's the small. So if I'm doing my formula, big is 9 plus x, and that's being multiplied by the small, multiplied by 9. That's going to be equal to the big, which is 27, times the small, which is 8. All right, so how do we do this? We're going to distribute the 9. So it's going to be 81 plus 9x. It's going to be equal to 27 times 8. Here, I'm going to do 7 times 8, which is 56. I'm holding the 5 on my hand, but you can't see that. So I'm holding the 5 fingers, and then I'm doing 8 times 2 is 16, plus those 5 that I have in my hand. So 16 plus 5 is 21, so 21. And now I just need to subtract 81, subtract 81. We're gone. We're left with 9x is equal to 6 minus 1 is 5. 21 minus 8 is 13. And then just need to divide by 9. Divide by 9, divide by 9. 135 divided by 9 is hard, but check this out. Did you know 135 divided by 9 is the same thing as 90 over 9 plus 45 over 9? Why did I choose 90? Because it's times 10. That's super easy. This one is 10, and 45 divided by 9 is 5. So the answer here is 10 plus 5, which is 15. X is equal to 15. All right. Moving on to, wait, I'm checking my answer. Yeah, I got 15. Okay. Moving on to, wait, where's 23? 23 is down there. Okay, well, this one is still the same formula. It's just a little bit trickier. It's, again, big times small is equal to big times small. This length is the big and it is the small, so it's this length times itself, which is 6 times 6. Forgot the L there. So this is going to be equal to 6 times 6. The big and the small happen to be the same length. And over here, the big is these two added together, right? This entire length is the big. Whoa, no, that's not that right. There we go. That entire length is 4 plus x. That's the big. So 4 plus x is the big. And it's multiplied by this small length of 4. Cool. So we have everything to go. Let's go ahead and distribute 4 times that, and we get 16 plus 4x is equal to 6. I was going to say 6 times 6, which is just 36. Let's go ahead and subtract 16, get this equation going. So when I do that, I get 4x is equal to 20. And then finally, divide by 4, x is equal to 5. Nice and easy. And we were solving for x, so I can box the x as well. Number 23 is 5. Moving on. Ooh, we're getting close. Is this the last page? Yep, and then we get the answers. So this is the last page. We're almost done. Here we go. Graph each equation. So just remember that you kind of do the opposite of what you're supposed to do. In terms of the x direction, aka the left and right direction, this would normally be thinking, oh, this left 2, right? You actually do the opposite of that. You go right 2. Anything inside the parentheses next to an x or a variable for that matter, you kind of do the opposite of it. And that is a rule that is applied through all of math. I can talk about why later, but we're just going to do it for now. This says right 2. So let me write notes to myself. This says go right 2. This would normally be the y direction, so it's up or down. This would normally be up 3, but you do the reverse of that, and this is down 3. And this here, it's not in the radius form. In order for this to be in radius form, it needs to be something quantity squared. Well, what quantity squared gives you 4? 2 quantity squared gives you 4. So that means that the radius here, the radius is 2. Radius of 2. So we just need to say, okay, the center of my circle will go right 2, down 3, and then make a radius of 2. So go right 2. So I'm starting here. I'm going to go right 2, down 3. 1, 2, 3. So that's where the center of my circle is. And then I'm going to have a radius of 2. So I'm going to go up 2, down 2, right 2, left 2, and attempt to make a circle. Technology, please. Thank you. And there's our circle. What about number 25? Oh, these are fun. Okay, so use information provided to write the equation of each circle. And I think I don't have the really hard, okay, this is the really hard one. I'm looking forward to that one. This one is super easy. So 25, you just kind of visually see, okay, the center of the circle is right there. That means I went right 3 and I went up 2. Therefore, if I'm sending instructions to myself, x, I want to say plus 3 because it's right 3, but you do the opposite. You do minus 3, quantity squared. Circles, you might have noticed the form up here. Circles always have a plus sign in between. If you do a minus sign, that's if it's a minus sign, it's called, what's this one that goes like that? It's like the 2 pieces of the circle are turned backwards from each other. Totally blanking on the name of that, but whatever. It's a plus sign, has to be a plus sign. and then it's going to be y. Okay, normally you'd be thinking up 2, so plus 2. That's the opposite of that. It's minus 2. Y squared is equal to the radius squared. So what's the radius here? You can count. Okay, I'm going 1, 2, 3. So the radius here is 3. You just need to square that, and you're good. I mean, it would be nice to say that's 9 here. Let's just go ahead and call it a. Let's just say you're 9. 9. Okay, so there's the equation you're looking for. Nice and easy. This guy, though, this one's a little bit trickier. So I'm going to make a sketch of what's going on, and then from, so the radius here is the hard part. I'm just making sure this is correct. This information right here is used to build the left side of the equation, which is super easy, right? We know that it's going to be x. You normally say plus 12, but you do the opposite. You do minus 12, 20 squared, plus y. Okay, normally you'd think, oh, you go minus 3, right? You do the opposite of that, and you do plus 3, 20 squared, and that's going to be equal to your radius squared. I'm going to leave it radius squared for now because we don't know what the radius is, but we know this other bit of information. Hey, this is a point on the circle, so this is where the picture comes into play. If you were to draw a picture, I'm going to go ahead and say my axis is down there. If I go, 12, so I'm going to say 12, negative 3, we're going to pretend is right about there. We're going to say that's 12, and this point right here is negative 3. I'm going to go to 15, negative 5. So here's 15, here's negative 5, and I'm going to say that point is on the circle. So I'm trying to find what is the distance of that line, because that's actually the radius. The radius, if I were to make this into a right triangle, I went right 3. This distance right here is 3. This distance right here is 2. To get from 3 to 5, I went down 2. So the triangle here has a length of 2. It has a length of 3. And really, this is just a Pythagorean theorem question. You can say, hey, a squared plus b squared is equal to c squared. And if I fill that in, I'm saying, really, 2 squared plus 3 squared is equal to r squared. And 2 squared is 4, 3 squared is 9, that's equal to r squared, and that's equal to 13 for r squared. And at this point, there's two paths. There's the brute force way where you take the square root of both sides and then do stuff, and there's the elegant way. I'm going to be doing it the elegant way because guess what we want? Do we want r or do we want r squared? We want r squared. We want it in that form. We like r squared. R squared is 13, which means this r squared is 13. So there's our answer. 13 goes there. Y plus 3 quantity squared goes there. Plus 1 goes there. X minus 12 quantity squared goes right there. And there's the equation that we're looking for. There is a shortcut to this one that you guys might have already found. Again, because this number, you never have to take the square root of it. You just find the difference of these two, add it to the difference of these two, squared again, of course, and then you're done. So what I would do if I was doing this problem fast, I'd say, 12 and 15, that's a difference of 3. Negative 3, negative 5, that's a difference of 2. Square those, add them together, and bada bing, bada boom, you've got your 13 over here. That's how fast you could do that. All right, and that does conclude all of the practice tests for geometry. So let me go through all the pages so you have the answer key. There's page 7, page 6, page 5, page 4, page 3, page 2, and page 1. That concludes Geometry's practice test 10